Howdy, howdy. The Sieve of Eratosthenes is one of the ways that the Greeks first understood the difference between prime numbers and composite numbers. You remember prime numbers, the numbers that only one in itself can evenly go into, and composite numbers are all the other numbers like that, with the exception of one, of course, which we've learned is neither prime nor composite. So the Sieve of Eratosthenes was just a process by which the Greeks would eliminate all the composite numbers, and as a result, we'd end up with a whole bunch of prime numbers left over. So we start off, we kind of ignore 1 because 1 has that property that's neither prime nor composite. But 2 is our first prime number. And so what we do is we cross out every number that's a multiple of 2. So I cross out 2, 4, 6, 8, 10, cross out all of these numbers as well because they all end in 2. These all end in 4, these all end in 6, these all end in 8, these all end in 0. So that leaves all of the odd numbers left over. And the next number that we have that isn't crossed out is this 3. So once I've got 3, I'm going to cross out 6, 9, 12, 15, 18, 21. Every multiple of 3 that I still see here, I'm going to make sure is crossed out. Now, half of them are already crossed out just by the nature of, they were crossed out earlier as a result of being even. 48, 51, 54, 57, and 60. And so I look, 4 got crossed out when 2 got crossed out, but 5 isn't. So I can cross out all of my multiples of 5. Now, all of these 10s, 20s, 30s, 40s, 50s, 60s, they were already crossed out, but 5, 25, 35, 45, 55, those were not crossed out, but they are now because they're multiples of 5. So we drop to 7. 7's prime, that means 14 isn't, 21 isn't, 28 isn't, 35 isn't, 42 isn't, 49 isn't, 56 isn't. And then my next one that's not crossed out, oh, it's this 11 here. And we keep going through and we cross out all of the multiples, but as you notice, a lot of these multiples have already been crossed out. As a matter of fact, at this point, the numbers that I have left, 13, 17, 19, 23, 29, that 26 got crossed out because it was even, 31, 37, 41, 43, 47, 53, and 59, those are all prime numbers. And once I get to a certain point, all of the numbers that are left over are prime. And that's great, but there's an easier way to do it. We did this in base 10 just because we're creatures with 10 fingers, so we do everything in base 10. But if we were to do this, say, in groups of 6, this becomes a lot easier. So of course, we ignore 1 because 1's neither prime nor composite, but I look at 2. 2 is even. So I'm going to cross out all the even numbers. Everything in this column is even, as is everything in this column, as is everything in this column. So my next number is 3, so I've got 3 here. But everything in this column is a multiple of 3. And of course, everything here was also a multiple of 3, but we've already taken care of it. So what do we have left? Well, we have this 5. So we have multiples of 5. So we have 25, 35, 45's already gone, 55. And then I've got 7, multiples of 7. So I've got 11, 13, 17, 19, 49 is the next multiple of 7 that I see. I've got 11, but we had 22, 33, 44, 55, and we're at the same point we were before, where all of these numbers that we've got left are prime. But what's interesting is that all of my primes fall in one of these categories. In other words, every prime is in this column where everything has a remainder of 1, or everything is in this column, which is a remainder of 5. In other words, I could say that every prime number can be written as 6n plus 1 or 6n plus 5. So if we were talking about bases, we would say this is modulo 6. Everything has a remainder of 1 or a remainder of 5. And that's really convenient because 2 times 3 is where I got this 6 from. Well, if I take a look at the next prime was 5. What if I do 2 times 3 times 5? What do I end up with? So looking at this, of course, we ignore 1. But here's 2, and everything here and here, half of these numbers are going to go away. And now I've got 3 as my next prime, so all of my multiples of 3 are going to go away. So those, the 6s, the 9s. Next prime I have is 5, and all of these multiples of 5 are going to go away. So these 5s and these 5s. Here I have 7. Now it's not as easy anymore. Now I actually have to do math, but 7, 14, 21, 28, 35, 42, 49. There's the first one I got that isn't crossed off yet. 56, 63, 70, 77, 84, and so forth. Multiples of 11, so I've got 11, 22, 33, 44, 55, 66, 77, 88, all done. 13, I've got multiples of 13, so I've got 13, 26, and I'm at that point where we were at before, where everything that's left is prime. And what I end up with is in this system where I have 30 columns, there are only 8 columns. The 1, the 7, the 11, the 13, the 17, the 19, the 23, and the 29. These are the only columns that prime numbers can come up to. In other words, every prime number is going to be 30n plus 1, or 7, or 11, or 13, or 17, or 19, or 23, or 29. In other words, I went from the previous table that we were just at. Notice on this table, basically 2 out of the 6 columns, or 1/3 of the numbers, were going to be prime. Now I'm at this point where I basically have 8 out of 30, which is much less than that, is going to be prime. And if I were to go ahead and use this 7 and take columns that went out to 210, I would get an even smaller fraction. And I would have fewer of these units, or fewer of these remainders, that would be where all of our primes are going to fall in. Now notice, I'm not saying that everything in column 17 is prime. I clearly crossed out a 77. Similarly, I crossed out a 49. But every prime number does have to fall in one of these columns. And that's one of the nice things about this modified Sieve of Eratosthenes. Have a great day.